Hi, my name is Richard.
And I'm Steve.
I'm John.
And I'm Steve.
Today, we're here to review about chemical nomenclature for the final.
In order to understand chemical nomenclature, you must first learn the polyatomic ions. The only way to learn the polyatomic ions is to memorize them.
A polyatomic ion is a tightly bound group of atoms that behaves as a unit and has a positive or negative charge.
In order to balance ion charges, you must first find the charge of the cation.
Then, you must find the charge of the anion. Finally, balance the charges of the cation and the anion with the number of atoms using least common multiple.
Now we do a few practice problems.
There are three different types of chemical compounds of which you need to learn. The type of chemical compound determines the nomenclature of the compound.
First, we'll start off with ionic and covalent bonds. An ionic bond is a bond between a metal and a nonmetal, or a polyatomic ion.
Covalent bonding is between two nonmetals. You can figure out if an element is metal or nonmetal by the periodic table.
An acid looks just like an ion, but the cation is hydrogen.
You will need to name the You'll need the name of the cation with a charge possibly, plus the name of the anion with the prefix IDE if necessary.
Then you will need to balance the charges.
You'll need to write the name of the cation with a Roman numeral only if the cation is a transitional metal, lead, or tin.
These are some examples of ionic nomenclature. In order to name a covalent bond, you must use prefixes to represent the subscript, in other words, number of atoms.
The first element use the prefix and the element name.
The second element also uses a prefix in the element name, but attached to the element's name is a prefix IDE.
Here are some examples. The first one would be carbon dioxide. Number two would be nitrogen sulfide. Number three would be phosphorus trichloride. The next one would be phosphorus tribromide. The next one would be silicon oxide, silicon dioxide. Um, Phosphorus tribromide would look like it'd be Br3. The next one, diphosphorus pentoxide, P5O5. Sorry, P2O5. And the next one, dinitrogen trioxide, would be N2O3. Now onto an acid nomenclature. There are two types of acids.
There are oxyacids, which contain oxygen, and there are binary acids, which contain no oxygen.
Binary acids contain hydrogen as a cation.
These are binary acids when you begin with hydro as a prefix and then add the anion, which is an IC at the end, and then say acid. For example, H2S is hydrosulfuric acid. Oxacids.
Well, first, if it's if an 8 ending, you change it to an ic acid. So for example, sulfuric acid, which is H2SO4.
If it's an ite ending, then you change the ite to os, and then you add the acid. One example is this is sulfurous acid, H2SO3. Here are some practice problems of acid nomenclature.
First one would be nitric acid. Second one would be acetic acid. Carbonic acid would be called HCO3. H2CO3. Nitrous acid would be HNO2.
And hydrofluoric acid would be HF.